Hi, I'm Alyssa Mello. I'm going to be doing a lesson in Regents Chemistry, which is typically for sophomores or juniors. I'm going to have my handy friend over here. His name is Adam, but he's going to be playing Ashley, who has autism. She tends to be socially disengaged a little bit with other students, but works really well with her hands and likes hands-on activities, which is why this activity will work really well, I believe, for her. As well as she would prefer to use drawings and voice recordings than writing a lot. So you'll see that in the activity part of the lesson. All right, so good morning, class. So today we're going to be doing a lesson in talking about heterogeneous and homogeneous mixtures. So let's see, what do we remember about heterogeneous and homogeneous mixtures? I'm going to use my name generator to see who's going to be called on it in the class. Ashley, what can you tell me about either a heterogeneous or a homogeneous mixture?
A homogeneous mixture has everything mixed all throughout evenly.
Very good. So yeah, homogeneous mixtures are going to be uniform in their appearance. So when you add, say, a solute and a solvent, they're going to be uniform and you won't be able to see a difference between the two. Can I push you a little further and can you tell me about a heterogeneous mixture?
Do I have to?
Well, I think if you do, because part of science is sharing with everyone, I think that would earn a classroom lottery ticket. How about now?
Okay, a heterogeneous mixture?
Yes.
A heterogeneous mixture, everything isn't mixed evenly. Like maybe there are clumps of it or something. It's just not even. I don't know.
Okay, all right, that's a good start. So in a heterogeneous mixture, that is true. So you're going to see clumps of it, or there might be, you're going to see a barrier between the two, your solvent maybe and your solute. Oh. So just like you would see, let's see, a common example is oil and water. And actually that's what I'm going to show you now in our demonstration. So before I forget, thank you for helping me out and answer. So hopefully you'll get to scratch it off later and see what you got. So let's take a look at some of these materials that I have up here. So I have my 2 graduated cylinders. I have some oil, some salt, and food coloring. We talked just a little bit before about oil and water, and we talked about how it's going to be a heterogeneous mixture. So if I add this in,
what's in there? What's the stuff on the bottom?
The stuff on the bottom.
What's already in there?
All right, make sure you raise your hand, Ashley, because I know it's very exciting, but we want to have you raise your hand. So, what we have in here, isn't that nice and separated like you said?
Yeah, they're different. They're separate.
They're separate. Can you see this barrier?
Right in the middle?
Yeah. So there are all these like bubbles, right?
Mm-hmm.
So in this case, like does not dissolve like. So these two are separate. They're not like one another. You can't dissolve this no matter how much I stir it or agitate it or increase the temperature or there was an increase in surface area. We learned that yesterday about those 3 different ways to how you can make a solution. But no matter how much I do to that, I'm always going to have this separation because it's a heterogeneous mixture. Does that make sense?
Yes.
Okay, so we have that one to look at. But now, if I take either my salt or my food coloring and add it to water, what do you think is going to happen?
I think you won't be able to see the salt. It'll dissolve in it. And I think the red food coloring, it'll turn pink. The water will turn pink.
The water will turn pink? Okay. So those are some good predictions, and that's important in science. So thank you for that. Let's see. So if I have my salt, here's a little bit of salt in there. Now, if you look real closely, it's in the bottom, right?
I see it. It's on, yep.
But wait a minute. Didn't I say this is going to be a homogeneous mixture?
Yeah,
So,
I said you shouldn't be able to see it, so why can I see it?
alright, so this is an example of why sometimes we need to stir the solutions in order to have a homogeneous mixture. So if I stir this, or even shake it, it dissolves.
It's gone.
It's gone, right? So tomorrow we're going to talk about why that is, but for right now you can see how this reemphasizes how stirring is going to make a homogeneous mixture, but again with only certain solutes and solvents. But we'll talk about that tomorrow. And now even if I add one more to this and I add my food coloring, and again, it's clumping, right?
I can see blobs.
It's blobs, right? But I said it was going to be a homogeneous mixture.
You have to stir it.
So if I stir,
It's pink.
right? It changed well, it didn't change color, but the blobs spread out. They dissolved in the mixture because that's a homogeneous mixture. So now, if I needed to separate these, let's start with our homogeneous mixture. How do you think I would have just separated my salt from my water? Thinking back to when we talked about this in lab in the beginning of the year.
Separate salt from water.
Mm-hmm.
Could you evaporate the water and make the water go away and the salt be left behind?
The salt will be left behind. Okay, perfect. So yes, when I evaporate off the water, you're going to have salt residue or salt crystals left in the either glass, or say if we were doing it in one of our evaporating dishes, you would now have the salt left out. So that's, you can use evaporation. If we're evaporating, is that a chemical process or a physical process?
Chemical?
Well, did I change the elements or atoms of either the water or the salt? Did the salt stay NaCl?
They stayed. So then it's just physical.
It's physical, exactly. So when we talk about solutions, I'll give you a tip. It's always going to be physical. We're never changing the chemical structure of our solute or of our solvent. It's always going to be physical. So that's a good example for our homogeneous mixture. Now our heterogeneous mixture, how are we going to separate that sucker out?
We should probably somehow, because the oil's on top and water's on the bottom, we should probably get the oil off it somehow. So I forget what it's called. Remember, if you pour like a little bit off and you have like the little
Careful
stick
with
thing.
it, but yeah.
So what do we? I don't know. I forget what you call it, but you do that to get the oil off the top, and then the water will stay behind.
Perfect description. So I know exactly what you're talking about. We're decanting it.
Oh.
So we're going to use our stirring rod. So that's great. So we're going to use our stirring rod, and we're going to now pour off some of the water or oil, whichever is going to fall off first. In this case, it's the oil. Now, if we had different liquids of different densities, something else may pour off first. But in this case, yeah, our oil is going to pour off, and we'll be left with water. It isn't perfect, but you can get the majority of it separated. And again, that tells us it's a what kind of process?
Physical process.
Perfect. Okay, great. So actually what we're going to do today is very similar to what I just showed you in our demonstration. So you're going to do your own mixture activity, and you're going to be making your own mixtures, both a heterogeneous and a homogeneous, following the same type of method that I just did up here. So what you're going to do is you're going to go to the back of the room where there are the labeled bins. See how mine's labeled? I was in group 1 per se. You're going to be in whatever group number it says at the top right corner of your paper. So what group number are you?
2.
2. Perfect. Okay. So you're going to find your other number 2 group members, and you're going to work with them together in order to make a heterogeneous and a homogeneous mixture. So you're going to go to the back and get your bin. Once you get your bin, you want to make sure you bring out your supplies onto the table, just like I did in the start. And you're going to think about what it is that we have. You want to first make a prediction, just like we did up here, where when you said that if I added my salt to my water, it would mix and create a homogeneous mixture. or when I added my oil to my water, it would not mix and make a heterogeneous mixture. So you're going to make some predictions on your sheet. And then, once you think that you have your mixtures ready, you're going to actually try it out with your graduated cylinders and make those mixtures. You'll probably have at least 4. But if you have 2 because you need more time, that's okay too. Yes?
That was a lot of directions. Can you help me do it maybe after I get my box?
Yes, absolutely. I will come around to each group to make sure that everyone is okay, knows what they're supposed to be doing, and can follow along the directions. You also have a written up here on the first paragraphs. It's written by step.
So I just do this. These are the directions you just
Yep,
said?
these are exactly them. So you're going to follow it step by step, like your checklist that you use for some of your other subjects. So you're going to be able to check each step off as you go along, with the first step being the easiest step, going to get your box.
Okay.
So I'm going to put my supplies back so I can get ready to help you. When you're all done, we're going to come back as a class and we're going to talk about some of our mixtures. Alright, so I also know that sometimes this could be a lot of writing, so I'll come over in a minute and show you, maybe some different types of methods that you're going to use for that, alright? So if you want to start in, go ahead and get your box. That'll be good. Alright. Alright, Ashley, so you have your box now. We have all kinds of supplies in there. So, are you able to follow the directions? Do you have any questions right now?
No, I'll just follow these.
Okay. So don't forget, if you want, I know it seems like a lot of writing, right?
Yes.
Okay.
A lot of writing.
And I know you kind of start to get frustrated with writing, so
I like to.
feel free to use you can voice record what you're doing as you're doing it, or you can use the classroom iPad if you want to draw pictures, because nobody else has called it yet, or needed to use it first. So if you want to share that or your voice recording, feel free to do that. Make sure if you draw pictures, you're labeling what you're doing, or if you did the voice recording, I can definitely understand what it is that you're doing as you're doing it. Does that make sense?
Okay.
Okay. Alrighty, I'm going to check on some of the other groups, and just make sure you raise your hand and let me know if you have any questions.
Okay.
Okay. Alright, it looks like everybody is just about done making their mixtures. Let's talk about some of them. Alright, so let's hear from, use my name generator, Ashley's group. Okay, let's hear from Ashley's group first. Tell me a little bit about your mixtures.
So I had to mix 2 things together with water. So I mixed the salt into one, and then I stirred it, and then I had some dirt in the other one, so I mixed that with the water, and that's what I got.
Okay, so you have salt and water and dirt and water.
Yep.
With your salt and your water, let's talk about this one first. Is salt going to be your solute or solvent?
What's the difference again?
Solute is going to be typically the thing that you add to your solvent. Solvents most tend to be liquids. Solutes tend to be solid in state. And usually solutes are smaller in quantity when you add them.
So the salt was the solute.
Okay, exactly. So your salt is your solute, making water your
Solvent.
solvent. Perfect. So now, and you stirred this too, right?
Yep.
So great. All right. So now, do you see any salt left?
No, it's all gone.
It's all
dissolved.
So that makes it what type of solution?
Homogeneous.
Homogeneous mixture. Perfect. Now then, I know by default that would probably make this one your What kind of solution or mixture?
Heterogeneous.
Heterogeneous, right? Had a 50-50 shot with that, but still, nevertheless, they're hard terms to manage. Now, how do we know this is heterogeneous?
Because the dirt is still separate from the water. Like the dirt's floating on top, and like the water's on the bottom. You can see them; they're separate.
They're separate.
Just like the oil and the water.
Did you try stirring it?
Yeah.
And nothing changed, right?
No, and we stirred it a bunch. I stirred it. My other group member stirred it, and then I just stirred it, and then I think you stirred it. Yeah, it just keeps. They're separate. They're not mixing.
It separates out. So how do you think, again, we would separate these two from one another?
So what if you had like a, or if you had like a filter or something, like I don't know, like my mom when she makes coffee in the morning, it looks just like this, and then she filters out the coffee from the liquid, and it's just like this.
And it's just like this. That's perfect. I'm smiling because that's a very perfect example, and in fact, I need coffee in the morning in order to get through my day sometimes. So yeah, that's perfect. So yeah, you're gonna filter it. We could filter at home, you can filter here. Both are relevant. This is why I like science so much, and I think why you guys should like science so much is because you do these things every day without realizing it. Although you may not drink coffee, your mom does. And maybe when you grow up and you go to college, you're gonna need coffee. And you're gonna filter it. And you're gonna say to yourself, that's a heterogeneous mixture. And you're gonna be like, Miss Mello taught me that. Doesn't that make you excited?
I hope so, yeah.
A little bit?
A little bit.
Well, thank you, Ashley, for sharing. So, now that we've heard from all of our groups, I just want to conclude everyone and make sure that you are then cleaning up your lab supplies, rinsing out your graduated cylinders, make sure you put everything back to where it belongs, and we're going to conclude and talk about why these mixtures are attracted to one another and why some of them are repelled by one another tomorrow. Alright, don't forget to hand in your lab activity sheets on your way out. If you need to make any adjustments, just see me. Ashley, are you going to need extra time with this?
I might.
Okay.
It's a lot. I'm gonna use the recording, I think, and it'll.
When's your free period?
8th period.
Okay. I don't have a class that period, so come back if you want any help, and just come use the free period, and I'll help you out. Okay.
Okay.
All right. Sounds great. So make sure we put everything away, and that we clean up, so that we're ready for the next class.
Okay.
All right.